Hello, and welcome to our live webinar, The Road to Digitalization Leads Through Cybersecurity, co-hosted by ISA and Siemens. Thank you for joining us today. My name is Don, and I'll be the operator for today's presentation. Before we get things started, I'd like to take a moment or two to acquaint you with a few features of this web event technology. At any time, you may adjust your audio using any computer volume settings you may have. On the right-hand side of your screen, you'll see the Q&A window. There's a large window which holds all of your sent messages and a smaller text box at the bottom where you'll type in your questions. To send us a question, please click in the text box and type your text. When finished, please click the send button. At the conclusion of today's presentation, we ask that you please complete a brief post-event survey. Please take a moment to complete this survey as it will help ISA plan future web events. We are joined today by our speakers, Eddie Habibi, founder and CEO, president of PAS, Leo Simonovic, he's the VP and global head of Industrial Cyber and Digitalization Security, and Steve Mustard, chair of ISA's Automation Federation Cybersecurity Committee. So with no further ado, at this time, I'd like to turn the microphone over to Leo to go over today's presentation.
Hello, everyone, and thanks so much to ISA for hosting this webinar. Today, we'll be talking about digitalization and cybersecurity. In this lies both the opportunity and a barrier. And what we'll be talking about is how we can overcome the core challenges to enable digitalization. Digitalization as a concept is a broad one. Just in oil and gas alone, the opportunity is sized at $80 billion. And yet, if you look at the oil and gas as an industry, it lags behind its peers in other verticals in its adoption. So what's at the core of this? When I talk to customers, the challenge that they articulate to me is that of cybersecurity. The fear that when they do get connected, they'll be vulnerable to attack. They tell me that the risk of connectivity outweighs the benefit. We know, however, that connectivity and digitalization is in fact a powerful force that can help businesses save money, become more effective, and identify alternative revenue streams. Today, we'll be talking about the threats, the opportunities, and how analytics, when used smartly, can help automation and industrial companies achieve digitalization. So with that, when we move forward to the core challenge, what we see is that the proportion of attacks either targeting or originating in the industrial environment have gone from single digits to over 30%. We had partnered with the Ponemon Institute to look at the state of readiness of the energy vertical to address this challenge. What they tell us is that, number one, OT, or operational technology, has become a greater concern than IT. And no wonder. When on the IT side, data gets stolen, you, of course, can be affected. Your reputation, your revenues can be affected. But on the industrial side, it could potentially lead to a catastrophic event. And yet, most in heavy industry and critical infrastructure are not prepared to address this. They're challenged by a number of different forces: increased risk, digitalization, and of course, incoming or looming regulation. We have seen that just over the last year, it's not just that the average attacks have been targeting the industrial environment, but that mega attacks have become the new normal. And so the question is, in this volatile environment, why would anybody connect? Why would anybody adopt digital as their core competitive advantage? So let me turn it over to Steve to talk a little bit about the threat landscape. What are some of those attacks, and what implications do they have on how we tackle the challenge?
All right, thanks, Leo. As Leo said, one of the drivers behind where we are today is that there is a desire to connect industrial control systems to other systems and to connect them to the outside world. There are significant benefits in doing that. And the assessment of that indicates that the risk is worth doing that. And one of the drivers for that is that we look at the layers of protection that are in place in industrial environments to ensure that even if there is a failure of the industrial control system, then there are other non-control system related controls in place to prevent a serious catastrophic incident. But interestingly, if we look at the incidents that Leo alluded to earlier, where they have been targeting industrial control systems, we can actually start to map those incidents, those attacks, to layers in the layers of protection. So if we talk about, for instance, Stuxnet, obviously very well-known attack, had exploited multiple flaws in the control system. But interestingly, one of the things that it did do is looked at masking the information from the control system to hide the fact that the process was operating outside its normal operating envelope. So we're targeting this layer here. Now, since then, we've had other incidents, well-known incidents, Havex, Black Energy 2, Crash Override, and so on. They've targeted elements of the basic control system. For instance, in the Ukraine, where we saw a major power outage affecting over 250,000 people for about 6 hours in the depth of winter, and no loss of life, but it was a very expensive incident for the electricity operator because they had to operate manually for a significant period of time after the incident because they weren't able to return the control system to automated operation. And part of the reason for that is that the attackers learned how to affect equipment in the control system level, including even things like serial to Ethernet converters and HMIs. And so we're now affecting this level. And then finally, the most recent incident that happened, just announced in December, affected the safety system. So there was a targeted attack somewhere in the Middle East, and it targeted a particular vendor's safety instrumented system, or SIS. And in this case, again, there was no serious fatalities and there was no serious incident, but there was a shutdown, which is a significant problem for the operator. And more worrying, I think, is that what we're seeing as a result of all of these is that the attackers are now understanding that there are how industrial control systems are constructed, what elements are in there, what products are in there, and what vulnerabilities are inherent in those products. And those products were designed with availability and performance and ease of use. They weren't designed for security, and so there are many flaws in those. And once the understanding of those flaws is more public, then we can see more and more of these kind of attacks coming in the future. They don't have to be targeted at particular vendors; they can be targeted at other vendors, for instance. And I know Eddie likes this slide. It makes him feel comfortable because he's familiar with this discussion. So what do you think, Eddie?
Oh, absolutely. This is a very representative slide as to what Leo was talking about, Leo was making a very good point that attacks on the industrial infrastructure is different from the attacks on the retail or information systems in general on the IT layer. Whereas if a bank is compromised, credit card numbers are stolen, digital information is transferred, and the damage is primarily monetary, it's financial, or in some cases might be reputation. In the case of the industrial infrastructure, as you pointed out, Steve, a successful attack can lead to very significant events, leading even into causing major blowout in a refinery or a chemical plant that could put a smoking hole in the ground. Now, if you have operated in the industrial sector, especially in the areas of process hazardous materials like refineries, chemical plants, oil and gas, you're very familiar with the concept of LOPA, layers of protection analysis, and that's what this picture is portraying. We have referred to this for many years in terms of control room situation awareness as it pertains to safety. We advocate very strongly that you must have good working process control loops in place, basic PID control loops that manage the process and keep rejecting the disturbances. If someone gets in and manipulates that layer, they can drive the unit to places where you don't want the unit to go. So a combination of manipulating the output out of a controller and then suppressing the alarms, which happened with Stuxnet, can lead to disastrous situations where the safety system is designed to kick in and bring the unit to a graceful degradation, shutdown. Now, one of the challenges in cyber that we have encountered is false alarms. There are too many alerts that a SIM generates or that a SOC, a Security Operations Center, has to deal with. And well, you have similar issues in a cyber environment as you do in the processing environment. And the way to deal with that is to manage and learn from the layers of protection in the safety arena and bring that to the cyber arena and say that we have to categorize the equipment that is being affected. By that, we have to extend that to the cyber assets, the controllers, PLCs, and other automation assets, and make sure that the alerts that we generate to the personnel on the ground are accurate and those that we can respond to.
Very good. So what I think is important, what Leo mentioned in the first slide, is about the complexity of the value chain that's in the oil and gas industry. And you can see in this visual very clearly the complexity that's involved there with the end-to-end process that's involved, but also the equipment, varying types and varying vendors. And this is growing all the time. So we're moving from just real-time information that was traditionally used just for safety purposes to more and more condition-based information that's really important to manage the equipment. And where we have more and more information, of course, we have to transmit that information to and from users, and that requires network connectivity. And when we do that, then we not only provide more information which is useful for the business, but we also make ourselves more vulnerable to potential cyber incident. Eddie, do you think, is there anything that you think that is important to mention on this?
Yeah, this is an excellent slide, Steve, in that it not only conveys the value of digitalization, but also it helps understand the complexity of the process in the manufacturing environment. If you look at this from left to right, you have monitoring systems, you have measurements. These are sensors, the endpoints that measure how the process is going. That combined with ubiquitous connectivity, whether it's in the field or in the boardroom, you have connectivity of information, all of that data being pulled up to smart, intelligent computers such as control systems and analytics engines to extract and squeeze actionable information out of field data. Phenomenal new opportunities. IoT, we hear all the time about Internet of Things. Well, what we are looking at on this picture is the industrial Internet of Things. And it is true, it is real, there is tremendous value proposition. We are going to come across value in ways that we have never seen before. Equipment health monitoring gets a new picture here because now we can share the information from multiple locations immediately because that data is interconnected through the net, through the internet, going up to an analytics engine that can provide actionable information. And all of that without adding additional equipment. It is just leveraging software, leveraging data, leveraging field instruments that have existed for a long time, extracting new value proposition. But the biggest
just to add to that, Eddie, I think.
Carry on, please.
No, I was going to say, just to add to that, it presents enormous opportunity, and yet it presents quite a bit of risk. And so I think you were going there already, which is that this requires connectivity. And most importantly, it requires indiscriminate trust from the field to the control room to the enterprise network. And the challenge is, how do you secure the information at the edge, the data highways on which it travels, and down the technology stack, from the controls layer all the way down to the sensor, because that information, with intelligence being pushed to the edge and down the stack, as well as up into the platforms, needs to be secured holistically. Back to you, Eddie.
Excellent point. So just to finish that thought, tremendous value proposition, minor additional cost in collecting that data that has existed there for a long time and extracting valuable information out of it. The biggest challenge is reliability of the data. Is it accurate? Is it normalized? And then security of that data. Interrupting the flow of that data through denial of service, manipulating that data to give false indications, or going in the other direction, writing back into the automation systems, into the industrial control systems that we have seen happen over and over the last 3 to 5 years, puts all of this infrastructure at risk. So
I think Eddie as well. I was going to say, to enforce your point, the important thing is that organizations become more and more dependent on the information to operate, and therefore any interruption in the service can cause a significant problem for the organization because they are dependent on that information. It's not just nice to have information, it's critical to the operation.
Absolutely. Absolutely. We have gotten used to, for example, for those of us on the call who come from an automation background, control systems background, we have gotten used to benefiting from advanced process controls. Advanced process controls can add 3 to 5% without modifying any underlying infrastructure, equipment, monitoring systems, etc. At level 3, it can add tremendous value. 3 to 5% of a refining capacity is way up there. It's hundreds of millions of dollars. Well, losing that for a few days through some interruption of service can be very, very costly. So there are significant risks when it comes to securing, when it comes to the IoT or industrial IoT that we have been benefiting from for a long, long time.
And so in this lies the question, how to take the incremental approach to address this challenge. It's complex, and if there's one word that I think summarizes all of this, in a world in which the probability of being attacked and that attack being successful is 100%, and that word is resilience. And the incremental connectivity that goes along with that, as well as the preventative measures. But at the core of this is transparency. So if we look at where most companies, industrial companies today, this was a survey again that was done by the Ponemon Institute and looked at oil and gas, is that 61% today are struggling to address this problem. They know they have a problem, but they don't know how to get started. And yet 72%, right, will rank themselves as either being in the early stage or middle stage of their cyber journey. So what are the problems that they're struggling with? Well, first and foremost is that of transparency or visibility. You cannot protect what you cannot see. Secondly, of course, is a shortage of personnel that understand and have a blend of controls, cyber, and networking skills. The reality is that if you look at the middle, that 72%, some of the really big companies are doing well, although they have a long way to go. But it's the middle that really struggles. And they struggle with unpatched assets. They struggle with fundamentals, configuration management, identity and access management. And most importantly, they cannot respond proportionally to the threat that they cannot see. So, what role can analytics play? We're talking about digitalization, the value of analytics, AI and machine learning. We hear all these buzzwords, which for those that are in the controls and automation business, we've been doing for the last 30 years. And yet, we haven't done it for security. And so if we look at where the aspiration and where most of the respondents that they want to go is that they want to use analytics to get that transparency, and yet only 20% are doing it today. And when we dug a little deeper to try to understand why that was the case, is it a question of tools? Is it a question of people? Is it a question of processes? Well, I think most of all, it was a question of complexity. Where to get started, how to use risk-based approach, how to scale security with digitalization, and have those go hand in hand. And so if we look at this, Eddie, were you going to add something?
Yeah, I was going to add that the analytics that you referred to in process controls have yielded tremendous value, and we should take lessons away from the OT community. The operational technology community is far, far ahead, in my view, in my very, very humble view, in terms of automation and optimization. What we see in automation and optimization in the business layer, as well as out in the broader industry, autonomous vehicles, etc., we have been dealing with in the operational layer for a long time, leveraging data to get some valuable, actionable information out. Now what we are doing is we're going enterprise-wide analytics of that industrial data. And that's where we can start cross-pollinating between lessons learned from the IT community and those from the OT community. IT folks know how to do cybersecurity. Frankly, as an automation engineer, being trained a long time ago, 3 decades ago, on how control systems work, security was the last thing on our minds. Production, reliability, and productivity improvement was the key focus of control engineers. We were not network engineers. We were not security engineers. So we were dragged into this as a result of connectivity. We found true value in the mid-90s. I remember very clearly where we went from proprietary air-gapped systems to adopting open network protocols requiring interfaces to the Windows environment, if you will, through the HMI and other means, to communicate the valuable data that we were seeing from the manufacturing floor to the management team, to accounting and planning and marketing, to make better decisions. But again, we did our part, IT did their part across the river from each other, if you will, never cross-pollinated. Hence this tension that was created over time between IT and OT. And where we have seen success in bringing about improved security is collaboration and teaming of the two organizations. They both have something to add, and this is where the points that you were making here, Leo, comes to play. We've got to bring the two disciplines together, leverage analytics, and recognize that OT is truly different from IT. Carry on, please.
Yeah, thanks so much for that, Eddie. I think, there's always a question that comes up. I'm isolated. I'm air-gapped. I'm safe, right? Well, as it turns out, 70%, whether advertent or inadvertent, of all incidents that happen in the OT can be attributed to insider threat. So that air gap doesn't make you safe. And in fact, if you look at a very important metric, which is the number of days that a piece of malware sits on an OT network, it is twice as long, close to 2.5 years, than that on the IT side. So connectivity, in fact, gives you insight and visibility and transparency, as long as you do it smartly. Audience, what you're looking at here is the puzzle. Many of us have the necessary elements to drive analytics towards the benefit or insight of cybersecurity. The magic formula that I like to think about it, and Eddie will get into this into more depth, is asset data plus controls data plus network level data. Today, a lot of the things that we do already around production, unplanned outages, asset monitoring, can be combined together. Those data depositories are disconnected. And bringing them together in blocks, starting with one layer of the technology stack, looking at which part of your operations is most vulnerable, using a risk-based approach to that. Combining risk and business priority is really important. Coming back to the example that Steve mentioned with Ukraine, the operator in that case didn't know for the first 4 hours they were experiencing a cyber attack. They thought that their DCS was malfunctioning. And I think in this lies the true problem, that a safety event could also be a cyber event, that an outage event could also be a cyber event. And the detection and combining those different pieces of the puzzle is the solution. The question is, now we know the what, the question is how. Where to start? we at Siemens have been in this journey for some time now and have been thinking about this problem. CAS has been thinking about this problem too. We've come to it from different angles, but I think what's important is to take the first step. And that's what Eddie is going to talk about in just a little bit. If we look at that equation, just right here, and I'll come back to the slide in between. Where do we start? Where does a lot of the risk and what I would call the data highway, the intersection in which it crosses? Well, you can start at the network layer. You can start at the controls layer, but the most important thing is to take the first step. And when I talk to customers about where they want to get started, right, it's a question of where they feel comfortable. When I talk to this community, the controls layer is the place where they understand it best. They know how to suck data out of the control system. They know what it means. Now they have to link those variables to cybersecurity. They have to contextualize it. And so what that contextualization means and how to think about it, which variables are really important, is something that we'll dive into in just a little bit. So before I turn it over to Eddie, let me come back to a few takeaways that we're thinking about. First and foremost, it's important to ask for OT dedicated solutions. IT has a lot of benefit they can bring to the table: experience, tools, but all of this has to be tested in the operational environment and has to work. Second, as we've talked about and we'll continue to talk about in this webinar, we have to overcome the fear of connectivity. Because of insider threat, because pieces of malware sit on our networks for over 2 years, because visibility is going to give us the insight and the power to react, which is really important. Getting that transparency in that first step is really key, understanding what you have and what that all means. Having somebody that's responsible and that can take that first step, really thinking about that complex relationship between the edge, the field and the control room, and down the tech stack. And of course, the piece that's most important is the analytics piece. So let's look at that equation, and let's focus on one of the building blocks, which is the controls layer. How can we use that to help us build the puzzle? Eddie, over to you.
Thank you, Leo. It's interesting that you highlight the uniqueness of OT. And OT folks, I am one of those folks, feel very, very proud, if you will, of the work we have done over the last 4 decades. Since the advent of the distributed control system, we have come a long way in improving productivity of plants. And there is an inherent trust between plant operations personnel, operators, superintendents, supervisors, and the maintenance folks, and automation people. That is, people in operations have come to trust automation as understanding what they do when they start messing around with the control system, making improvements. However, the reality is IT folks have worked traditionally around the business layer, and they are not as comfortable around the industrial control systems. And they have yielded over the years to control engineers and control system administrators to deal with those matters. So I had a conversation. I was at a conference and had the opportunity to have a conversation with a couple of executives about their security posture and what they are doing about their business. And a couple of key points came up. One that was resounding and very interesting was the fact that, look, we are talking to you, PAS, we're talking to you, Siemens, about our security posture around the OT because we know you have been in the business of plant operations on the floor for, in the case of PAS, 25 years, in the case of Siemens, for 150 years. And there is an inherent trust with our operations people, with production folks. But we are somewhat leery, somewhat concerned with purely IT folks going in and putting devices on their networks, on their process control networks, or trying to make changes to their process control architecture and environment. Well, that trust is something that comes over time, and I think IT people recognize that they need to rely on their OT partners at the plant to bring that capability, and vice versa. OT folks recognize that IT understands cybersecurity and can help. That was part of the conversation. Another part that really stands out very clearly is related to what Steve brought up earlier in the conversation here, and that was the Triton Tricep attack that was revealed that was exposed by FireEye and Dragas back in December. So this is a story, this is a true story that came in this conference. I was talking to this gentleman, this executive from one of the oil companies, and he said, we suffer from lack of visibility to what we have. The first question, he said, that I am asked after every breach, after every attack that gets publicized, whether it was Stuxnet back 7-8 years ago, or Havocs, or the latest one, Triton, the board and the executive management asks the question, are we affected by this latest threat? Because the role of management, the role of executives is to understand and address risk. And they want to understand. And the way you understand whether you are at risk or not is, hey, this Triton attack was on the Triconics safety instrument systems. And the first thing I need to understand, do I have those in my infrastructure? So they sent a question to the CISO. This is the CISO I was talking to. He said, I was asked how many of these systems I have, and of course, they didn't have an inventory of their system at the time. He said, I sent a note to all of my refineries asking whether we have the Triconic system. What came back was, yeah, we have about 6 of those. 6 of the sites have Triconic systems, and 6 sites were at risk. Well, the CISO later found out that Triconics safety instrument systems is a standard in this company. And they have it at every one of their sites, not only the refineries, but also the upstream and the farther downstream, midstream systems. Hence this notion that your ability to avoid risk, your ability to understand threat depends solely on the foundation of your system, which is, what do I have and can I manage the risk? And that's what we refer to collectively as endpoints that matter. We have worked with a number of majors in power as well as oil and gas industry who tell us that invariably they find out that roughly 20% of their manufacturing assets, cyber assets, are made up of level 2 systems that are easily discoverable. These are network devices on the PCN where the operator HMI resides. By the way, what you're looking at on this slide is the Purdue model exposed to show level 0, 1, 2, 3, 4, 5, with emphasis on the manufacturing level, the level that is the most important when it comes to the safety, reliability, and the security of a manufacturing plant. And that's the part that unfortunately gets overlooked. The levels 0 and 1, the foundation, the production-centric endpoints. And roughly speaking, in the assessments that we have done over the last 20 years or so, there are about 80%, there's about 80% of the cyber components from field instruments, smart field instrumentation like sensors, pressure sensors, flow and temperature sensors to valves and compressors, compressor monitoring systems are make up at level 0 and 1 controllers and I/O cards, and then 20% are at the IT level, which are easily discoverable. So what does all that mean? That means we've got to approach security of a plant with the very basics. Go back to the basics. It's almost like safety. I look at security, and truly, I leverage what I learned in the safety environment. There is a regulation called Process Safety Management. It's an OSHA in the U.S., OSHA regulation 1910.119, that outlines 16 basic principles that companies have to do to make their operating plants safe. So learning from that, we have defined what we call foundational industrial control system cybersecurity. And these are, again, the very basics, such as, do I know what I have? Do I have an accurate inventory of my automation systems, of the ICS? Do I have a security framework? Do we have a policy that we want to adopt, whether it's NIST or ISA or NIS that's coming out in Europe shortly here? Do we have a framework that we can adopt, abide by? Any standard is better than no standard, so let's pick a standard and go by a framework. After that, we want to understand our risks. There's no way you can understand your risks if you don't know your inventory. Finally, having a backup of the system just to be able to recover is extremely, extremely important. The next area that we focus on, that we believe is phase 2 of a project like this, is understanding, after you understand what these vulnerabilities are, is addressing those vulnerabilities, putting in place an effective management of change, training the personnel, and putting in place some network monitoring and intrusion detection. Finally, metrics reporting becomes extremely important from a central standpoint, allowing everyone from your security operations center folks to the executives on a daily basis understanding what the risks are. Very similar to a safety risk dashboard, understanding your independent protection layers. Think of your defense in-depth strategy, just for the OT folks, as your independent protection layers. Your firewall, which, by the way, is not on this pyramid. We have a footnote here that says it's a given that you will have put in place firewalls and antivirus and physical barriers, physical security in place. The idea here is that you have to have a framework to work within, and you have to deploy specific independent defense layers to deal with threats that exist in the cyber world. So let's examine this one at a time and see what all of this means to us. Inventory. One of the biggest challenges we have right now in the industry is understanding what you have. Imagine if you own a house, and it's a big house. It's a very big house. It's a Bill Gates kind of house, and you have hundreds of windows and tens of doors, and you want to bring in a security company to secure your house. One of the things they do is put sensors on your doors and windows for an alarm system. Well, actually, if you don't know how many doors and windows you have and where these doors and windows are, you can't secure your house. You may be able to of the 100 windows, you may be able to find 20, 30 of them, and of the 50 doors that you have, you may be able to find 10 of them. The rest is vulnerable. Monitoring 50% of your doors and windows does not provide for good security. So having an accurate security inventory of the system becomes absolutely essential. And the way we have seen people do this is rely either on original documentation that were delivered by automation vendors of various types, some of which have been in place for 20, 30 years, or get a tablet or a spreadsheet and ask the control system engineers to go out, open cabinet doors, and find how many of Honeywell TDC3000 or Experion system, how many Delta V, Emerson Delta V, or how many Siemens PCS7 they have. It's just untenable. It's just impossible, both from an accuracy standpoint as well as an effective standpoint. And, of course, I keep iterating. You can't understand your risks. You can't understand your vulnerabilities unless you understand what you have, the endpoints that make up the inventory. So what's needed is an automated method to capture all of that. Now, what makes up an inventory? What is an inventory? There are basically two levels of inventory. One is what we call basic inventory of your manufacturer, make, and model. What controller do I have? What I/O card do I have? And what sensors do I have? Now, mind you, this is manufacturer, model, and version, but you must capture level 0, level 1, and level 2. You can't just look at devices that are identifiable by passively listening to a process control network. You have to understand those controllers that may be of old models that may not have an IP address, I/O cards that may not have IP addresses. Yes, Leo, would you like
to add to that, Eddie? Yeah, just one word. And I love your analogy about the house in thinking about the windows and the doors that need to be protected. And then the question is, which door or which window has been left open? And the other question is, what is the likely pathway for an intruder to come in? And the layer 1 and layer 2, when I talk to customers, and Eddie, like you, we visited many customers together in oil and gas and utilities. Asset inventory is the core problem that they're looking to solve, and most of them are still doing it with spreadsheets. The question is, how and why, what implications does a particular PLC or RTU have on the production process? And prioritizing those inventories to help you figure this out becomes really important, because the reality is that a single PLC or a set of PLCs can have enormous implications on production. And so capturing the depth of your inventory and doing it systematically is the crux of the problem that you and I have been solving together.
Absolutely, Leo. The analogy speaks to a couple of other challenges that as soon as this slide builds here, it looks like it's building really slowly. Look, knowing what you have, the endpoints that make up manufacturing, and what you see at the bottom of this slide is the DCSs, the SIS, even the historian, those systems that you would traditionally think of as IT assets. In some companies, the historian is managed by IT. Those make up the production systems, the SCADA systems. Those obscure compressor control systems that were put in place 20 years ago, or vibration monitoring systems that were put in place 20 years ago, we have to have visibility to all of those, because unless we do, we cannot understand our vulnerabilities. Again, I am highlighting the foundational ICS cybersecurity components that we must put in place before we worry about anything else. we just talked about the house with doors and windows. Next area is configuration management. Configuration management is something that has been around and understood in the IT arena for at least 2 decades. Companies have been providing configuration management solutions for IT systems for a long time. Unfortunately, at the OT layer for control systems, PLCs, etc., as control engineers, we have not been as, if you will, concerned about configuration management because, generally speaking, a control engineer or two at a given unit, process unit, understand the configuration of these systems so deeply that they feel they can point to any part of it, and because they are the only ones getting in there and making changes, they are comfortable with it. But times have changed. Because of resource availability, we bring in contractors to help us out, consultants to get into our control systems to do work. Configuration management becomes extremely essential here.
Eddie, one of the things that the IT world has the benefit of, though, is that there's a lot of standardization on the products that are used. Windows is the de facto standard, and SNMP and other things have been well established for a long time. So I feel like it makes the IT world, their life a bit easier in terms of configuration management. Whereas in the OT world, we have a whole raft of different protocols and vendors and standards. And it's very difficult to come up with a simple way to do that.
Excellent point, Steve. Thanks for bringing that up. I'm going to point here, if I can use this pointer, to configuration management. Look, what you have in the IT world are systems that over the last at least 2 decades have become so standard that I can extract information out of an SAP system and an Oracle system, accounting systems, etc. For control systems, I have a number of challenges that make it difficult to pull data out of these systems, and I'll elaborate on those. If you walk into a plant, an industrial plant, whether it's a water treatment, power generation, or chemical manufacturing plant, the following is a fact. You have selected best-in-breed systems, meaning that your level 0 instrumentation comes from 1, 2, or 3 different vendors. Your ICS, your distributed control system, the DCS and the PLC come from a couple of different vendors. And the layers above that, the historian or the advanced applications, come from different vendors. A major power company told us that they have, at any given plant, at least 30 different, that's 30 different systems and applications they have to manage from different vendors. And then you have multiple generations. I've been to sites where they have 3 generations of the same vendor's distributed control systems. And then you have the proprietariness of these systems, every one of them with proprietary protocol that makes it difficult to extract the deep configuration of these systems to manage. So multi-generational, multi-vendor, and very complex and proprietary systems makes it very difficult. Then the next area is compliance management. Can I see whether I have complied with the standards that my company has put forward? You know, the power industry is far ahead of other industries in the U.S. in terms of regulations. And companies in the power industry have been very responsible in the U.S. over the last 7-8 years, complying in this area. But the very first thing they need is inventory and configuration management, change management. I'll go back to the analogy that I gave earlier about the house. Imagine that I have a contractor coming in to do some work at my house, which, by the way, I did. Last week, I had a plumber visit us at least 3 times. We had a terrible freeze in Houston, and a couple of our pipes burst, and we had a terrible mess in the backyard. It was an outside pipe that burst, and because of the freeze. Now, imagine I live in that 100 windows, 50 doors house. And it happens to be that this plumber, and I don't want to pick on plumbers. Plumbers are my favorite trades. Tradesmen do a fantastic job. So they come in, but this particular plumber is not a nice guy. He goes and mucks around my alarms. He disables some of the alarms to a few of the windows so he can come back later and intervene and take things out of my house. Well, that could be the scenario of someone going into your control system, making changes. I'll talk in a minute about the trisis. Imagine if that trisis attack, triconics attack, had not led to an interruption in production and a shutdown. Imagine if someone had disabled the alarm or the trip on that triconic system with the intent of coming back later on to push the production, push the process to beyond its limits of operability. That one most important layer of protection, which is for safety, would not be there to protect you. Hence, configuration management, compliance management, and finally, backup and recovery, very critical to the operation of the plant. We should assume, automatically, as we do in safety, that worst-case scenario can happen. We have to be prepared to deal with that. So I'm going to specifically put some spotlight on some of these areas. Vulnerability management, the biggest challenge is having visibility to what you have and then matching up vulnerabilities to your inventory. It seems like a simple value proposition, but if you've ever looked at the vulnerabilities that exist, whether from National Vulnerability Database or from ICS Search, there are tens of thousands, upward of 100,000 vulnerabilities. For the control systems, the number of vulnerabilities is fewer, but matching those up with inventories that go back a few years is very difficult. So having an automated way to detect vulnerabilities and time up to your assets is very important. More importantly, it isn't just saying, hey, we have this particular, I hate to pick on Schneider's Triconics. That is a phenomenal system that has saved many lives over the last 35 years. But unfortunately, it was compromised. It happens. It will happen to other vendors invariably. But it isn't enough to say, yeah, we have Triconic systems at 35 of our facilities. You have to know where those Triconic systems are and what physical assets they are connected to. And you have to be able to do that automatically. And you have to be able to do that within an hour or two when the vulnerability is exposed. Hence, the need for automated detection and notification through a managed service of some sort, whether it's company, SOC, or an outside firm like Siemens MSSP. I'm advancing the slide, and it's not cooperating as fast as I'd like it to. Here we go. The next area is configuration management. I think I spoke to this. Being able to immediately get a notification that, hey, one of your Windows alarms was tampered with and disabled. I'm talking about the house again. And addressing that is extremely important. So being able to get a notification that the trip on a shutdown system was bypassed will help save a lot of headache. Now, earlier in the conversation, Leo mentioned, I don't know what percentage it was you gave. Was it 70 or 80% of vulnerabilities are internal threats, insider threats?
Yeah,
I think
insider threat makes up around 70% of all attacks, sources of attack in the OT environment.
The makeup of these threats is twofold, and I'll talk to that in just a second. They come from intentional attacks, if you will, by a disgruntled employee who is still employed, or someone who has been fired but has credentials, whose credentials haven't been remediated, or a contractor, or a malicious actor from a nation state who disguises as a contractor and enters your environment. Those are internal attacks. But in our view, very similar to safety, majority of these vulnerabilities come from inadvertent mistakes. Somebody goes in and bypasses a trip to do the annual OSHA-required safety trip test. This is something operators of hazardous chemicals have to do. On an annual basis, they have to make sure the availability of their shutdown system. If you forget to re-enable that trip, that's an inadvertent time bomb due to human error. The only way to capture those is to continuously monitor the configuration of every PLC, every shutdown system, every distributed control system to make sure you understand the changes. In fact, put in workflow processes and automated notifications so that a disable of a critical alarm or a shutdown system is reminded to the proper authorities within 24 hours or 48 hours. So we remember to go back and make the correction. Compliance management, very important. In the power, we've had it for a long time where outside authorities come in and require that you show compliance. Internal auditors want the same thing. How quickly can you show compliance is very, very critical. It's time-consuming, and the accuracy of it is very critical by the auditors, be it internal or external auditors. Let me see here. The slide doesn't show very clearly, but what you're looking at is compliance audits, backup and recovery. Again, we must assume, just as we do safety, that inadvertently or intentionally, things will happen. We must assume worst-case scenarios. What do you do? Now, we have specific situations that I can draw an analogy to. I've often said a major cyber attack is not too dissimilar from a major natural disaster. Here in Houston, we have been through a number of them. I've lived in Houston since 1978, and I've been through at least 4 major hurricanes that have totally disabled the critical infrastructure. What is the critical infrastructure? Power, water, transportation, completely knocked out for a number of days. Well, in a couple of those instances, we had some of our customers, I won't name the customers, one of the top 5 major oil and gas companies, equipment room in the basement was flooded. And as a result, I think that was Hurricane Ike, flooded the control room, and this was an older control system. They did not have a backup for it. The backup they had was a year old. They went to the configuration management software that they had from our company and managed to recover the control system within a week once they got everything cleaned up. Now, this would have taken months to bring the unit back up. So even if it is not a malicious cyber attack, you must consider worst-case scenarios, that systems will fail, that natural disaster will hit, and you will lose your system. Do you have what you need to back up? That's a question executives who are enlightened will ask on a regular basis of their managers.
And then just to add to that, you got to pair that up with an incident response plan and the ability to deploy resources in an orchestrated way to do that backup and recovery. And so understanding the different parts of your equipment, right? Install base is going to be really, really important to that, but also understanding what elements need to be backed up and by when for production to back up is really important, because in those crucial moments when things go down, you got to figure out what's essential and what's not.
Absolutely, Leo. The next topic, of course, my slides moved a little fast. Here we are. This is a case study that I want to share with everyone, and I'll share a couple of others. We have been through a number of these. Inventory management. So we have had a number of refineries, refining companies that we have worked with. By the way, I really should give kudos to the oil and gas industry, whereby they take in the proactive approach to securing their assets and not waiting for regulation, government regulation, to come and ask them to do so. These are very automation-intense processes. We have this one particular customer of ours with 10 refineries, at least 50 distributed control systems from a multitude of vendors, with over 2,500 cyber assets that they had to secure. And when I say cyber assets, these are controllers, operator stations, and I/O cards, etc. And we managed to help these folks out, and using cyber integrity, roll out an automated inventory management system for them, which actually gave them tremendous benefit. One of the questions that I've always asked in safety, it became very clear that safety is something you must do. Yeah, it's cost. Pardon me. It's cost, and it doesn't have direct ROI, but if you implement good safety, independent layers of protection, invariably you improve your reliability. Invariably you improve your controllability of the process plant. We see similar opportunities in cybersecurity, whereas an antivirus has no benefit other than detecting viruses. You don't call it up and ask it to provide you information that's not related to cybersecurity. Pardon me. A complete inventory of your assets will help you in a lot of different ways. First of all, the benefit of an automated inventory is reduced cost. You take out a tremendous amount of labor. In a different case study where we had a major American power company was conducting cyber asset inventory manually, they were spending something like 40 man-years, literally 40 man-years to collect inventory of about 70 generating units. That's just way too much cost. You can reduce that to a couple of people who manage the configuration environment and the system, if you will. The second benefit is, of course, hardening of these systems. But the third part that is really, really important, that brings clear ROI, is exposure of the configuration of these systems that help you in database migration to a new system. We have a lot of legacy systems where the same configuration management solution that you use for cybersecurity becomes very helpful in migration of control systems. It becomes very helpful in the day-to-day activities of control engineers, understanding what configuration they have underneath. So lots of benefit that come from foundational cybersecurity that is beyond what you would get from a firewall or an antivirus application. The next slide, I believe, tries to pull all of this together, and I would like to ask Leo to take this one, if, of course, I can get to the right slide. It ties it together from aggregating the data to analyzing it and providing actionable information. Here it is.
Thanks, Eddie. We started the conversation by talking about digitalization and its benefits, and also the barriers to its adoption. Then we went to the analytics and the power of analytics to help us. And then the first steps that we can take to help enable the detection, contextualization, and then response. So what Eddie talked about is the importance of understanding what assets you have, prioritizing those assets. From there, matching up against existing vulnerabilities, and then actually doing something about it. In this, what we would call the resiliency or the improvement of your readiness is one part of what needs to be done. The second, of course, is monitoring, and the third is the response piece. We think of a good OT cyber program as having all three. So the analytics, enabled by connectivity, give you that visibility. And the next question is, well, how do you do that matchup? Right? What's important, and this is a question that came up around insider threats. What's inadvertent? Does it matter if it's inadvertent or it's done on purpose? Well, in some ways it does not, in a way that it doesn't matter whether, at least in the first few minutes, where the trigger for the safety event occurred. What's important is that it's happened, and then you need to be able to respond. Of course, we then go back and investigate and do the forensics to figure out the sources, and then try to figure out where the root cause analysis and try to fix it. So the key is doing the detection automatically. It begins with understanding, hey, who plugged in that USB onto my network, detecting that event, and then figuring out what's happening in real time. That's inventory management. That USB stick, right, or that laptop that's been plugged in is an unknown device that should not be on the network. Okay? So take the flip side of asset management and you suddenly say, well, wow, I'm connected, I understand what I have, and in real time I can detect whether something's changing. That's what Eddie talked about, configuration management. That's the flip side of it. And then the question is, what do you do about it? Because you're running a plant, it's very costly if you shut it down for an outage to deploy a patch. And so the trade-offs of doing this is the other piece. So this is what we call scenario mapping. And then from there, coming up with a schedule, because eventually you got to fix the stuff to do something about it. So in terms of takeaways that we think about, and we'll go to questions in just a second. The biggest takeaway is the connectivity equals insight. Second takeaway is that the words that you already know today are the pieces of the puzzle that can help you get started. You have already the majority of the puzzle in your environment. You just need to link it back up and bring it into a single view. And then from there, the last step is to be able to prioritize that continuously. Okay. Let me open it up for questions. I know we have about 15 minutes.
All right, excellent.
So,
I'll remind our audience that the Q&A panel is located on the right-hand side of your screen. To submit your question, please type your question in the small text box at the bottom. And when finished, click the send button. Please note that due to time constraints, our panel may not respond to all the questions submitted. So at this time, Leo, I will defer to you and the panel for questions we've received from our audience.
Sure. We'll start with a broad question. And this one goes to Eddie. With respect to cybersecurity, what are your perspectives on the roles and responsibilities of asset owners, operators, as well as equipment manufacturers, regulators, and trade associations?
Wow. Somewhat of a policy question. I believe collaboration is the single word that I want to apply here. Collaboration at all levels, government agencies, manufacturers of control systems like Siemens, and end users, plus academia and consultants. We see good work coming from every one of those organizations that I just mentioned. Look, I have a basic philosophy. You put engineers in separate rooms, give them a problem. They typically come up with a solution that is somewhat similar. But the best solution comes from when you get people from different disciplines and different concerns together and give them a problem. Invariably, every time they come up with a better solution. So I'll address that in just a minute with the following. I believe, first and foremost, major world leaders need to come together and develop a framework or an alliance around cybersecurity, especially for the industrial infrastructure as well as military installations and weapons of mass destruction, if you will, nuclear weapons, etc. There has to be some kind of alliance and agreement as to what are the rules of engagement when it comes to cybersecurity. Thou shalt not attack one another, and thou shalt get together and defend each other and share information, if you will, in terms of cybersecurity. I believe that there is currently some committees that are pulling academia as well as manufacturers and end users together to make improvements. I see some issues in Europe right now. I think NIS is coming out as an umbrella guideline for managing cyber threats. However, it is left to individual countries on how they interpret and implement NIS. I think that's a challenge. But to broadly address it, collaboration is the key.
And just to add to that, we at Siemens see ourselves at the center of this challenge. We're part of the ecosystem, the glue that brings our customers, our partners, and our suppliers together. And that's why a comprehensive approach and a set of playbooks is required to address this challenge. A set of practical solutions for all of us to work together in tackling this. Of course, compliance is important and it gives you a baseline, but we need to go beyond compliance towards a risk-based approach. That's why we stood up a business that's focused on the OT cybersecurity from the ground up. And I think that naturally transitions into the next question. And I'll take this one. What is the very first step to implement cybersecurity in industry? I assume what the participant is talking about here is operational technology. The first step is to have a strategy or a concept for a cyber program. It needs to have a responsible owner. It needs to have an understanding of what the gaps look like. We at Siemens, depending where you are in the world, there's either a regulatory framework or set of standards or best-in-class leaders that can be that benchmark. It'll help you mature. Then, figure out what the operating model, once you know the gap, then you can begin to address fundamentals. The first step in all of this, I think we talked about it, has many words, but understanding what you have, prioritizing it, and then closing the vulnerabilities that are associated with it. Next question. How secure by design can help in reducing worries and the protection, enhance the protection of assets? So with that, actually, let me turn that question over to Steve, and then I'll let the panel comment.
I'm sorry, Leo, could you
repeat that?
Let me Let me take a shot at that, Leo, and then Steve, please feel free to chime in to the how secure by design can help. Look, I mentioned earlier that I have never been to a chemical plant, refinery, or power plant that had the 20, 30 different components of automation systems, industrial control systems, from the same vendor. The challenge is secured by design is not something that you can go back and retrofit to a Honeywell control system or a Siemens control system from the 1980s or the 1990s. That applies to new systems that come in. Secured by design is good. We have to demand that from manufacturers, but we must also recognize that even secured by design from multiple vendors are still not going to talk to each other. We're going to have interoperability made possible, and those systems then have to be made secure. You will still have to do the very basics, the framework of a security policy, and then inventory, change control, change management. All of those layers will still apply, but secured by design is a good starting point. Steve?
Yeah. So, good, Eddie. Yeah. What I would want to add is that the way I look at secure by design is if you compare that to the hazardous area classification for equipment, it's not possible to buy anything, or you certainly shouldn't buy anything, to use in a hazardous area unless it's got a certification already to prove that it's suitable for use in a hazardous area. That I look at secure by design like that. I want to be able to buy a product that is being certified that it can be used in a secure application. But as you point out, it's very dangerous to assume that if you buy something like that, that is it and security is done. Just like in the hazardous area environment, just by buying something that's certified does not mean that you have to, you can circumvent any of the other controls that you need to have in place for working in hazardous environments. So you have to put in place, like Leo says, the whole strategy and the management plan around it to make sure that you can buy those products and use them, but you have to do other things as well to maintain the defense in depth that you need for secure operation.
Great. So one question that keeps coming up is around data diodes and the value of this. And I'll take this one and I'll let the panel comment as well, if they wish. Data diodes are an important ingredient. I think of cybersecurity, and especially on secure architecture, secure by design, as providing a blueprint. Think of it as a recipe box. Data diodes are an important part of that, especially in critical zones. But the question is, what is the problem that you're looking to solve with a data diode? Oftentimes, the challenge when I talk to customers and they say, hey, Siemens, PAS, how can you help us? Data diode is our panacea. Well, as I think we made the point around, being isolated or having just one-way communication is not going to give you the visibility to drive change, to drive agility, to be able to respond. So the way that we deploy data diodes is we say, first and foremost, well, let's look at your security architecture. Let's look at what you can begin to monitor. What are those critical assets? And it has applications. And we deploy data diodes in using a layered or defense in-depth approach, but to solve a concrete problem, which is that how do we enable detection and, of course, response?
Good point.
Yeah, Leo, I agree with you. I think that sums it up very nicely. It's everything that we have in the armory of cybersecurity protection is there and it's available to be used in the right circumstances. I think we do have to be careful that we understand, as you say, the purpose, what we're trying to achieve, and then use the right tools from the armory as appropriate. So it might be that it's industrial firewall with particular functionality. It might be a data diode. It might be a traditional IT firewall. It might be some completely different control that we have in place. And I think, as you say, it's important to emphasize that isolating ourselves is not a comfort blanket that we can have to say that we don't have to do any of the other protections like manage removable media, for example.
There's a question that just, I know this on the list. I want to ask this of Leo, and that is, it seems like, based on what you guys are showing, there are, let me see, lots of solutions I have to get from different vendors. The question is, how do I address all of these different parts and pieces and have a single throat choke? I think that's what's implied by that question.
It's a good question. So I live in Washington, D.C., and in Washington, in a very small area, there are 1,600 cyber companies that claim to do very similar things. Lots of our customers are confused, right? So we at Siemens have thought long and hard about this, how to bring the best-in-breed solutions together so that they work. I mentioned this concept of a puzzle that needs to be solved. There are different building blocks to that puzzle: vulnerability management, anomaly detection, cyber asset management, incident response. From our experience, it's a question of how to bring them together to solve the problem of for the customer and give them peace of mind, so they can go back and really focus on the things that are important to them, which is production, efficiency, safety. And so going beyond the noise, I think is really important. And pairing solutions that can work with one another. Take monitoring, for example. Anomaly detection identifies the problem. A solution like PAS can help you contextualize that problem and also deploy some specific vulnerability fixes to address it. And then, of course, we at Siemens pair that up with incident response and our managed service. Really need a holistic approach to address this. So I think that's the last of the questions. Really appreciate everyone's time. Look forward. We'll take questions offline as well. I know we'll have this presentation available. If you missed a particular portion, really appreciate this. It's an important topic for us and something that we're continuously working on. Eddie, Steve,
I want to echo that sentiment from Leo. This has been a great conversation, Steve and Leo. Thanks for the opportunity.
Yeah. Thank you, guys. Very good discussion and very good questions from the audience. Thank you.
All right. On behalf of ISA, I'd like to thank you for your participation in today's event. If you missed any portion of this webinar or would like to rewatch the recorded version, we will be emailing all registrants a link to the recording along with additional links for supporting information. A post-event survey will soon appear requesting your feedback. We ask that you please take a moment to complete this survey, as it will help ISA plan future web events. That concludes today's program. Thank you, and have a nice day.